and Assalamualaikum to our Madam Ini Imaina. We are from Group 8 of A4CS1121C are about to presenting our calculus video presentation. But first, let me introduce you to our group members. First, Ilya Idrina binti Imran. Second, Tufatul Izzah binti Saiful Zaman. And lastly, Nurul Sharina binti Muhammad Zaki.
What is differentiation? Differentiation is a method of finding the derivative of a function. Differentiation is a process where we find the instantaneous rate of change in function based on one of its variables. Why differentiation is used? Differentiation allows us to find rates of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve.
If you don't start a conversation.
So let's start with the question. So step 1, we're going to take information from the question given. Notice that we have already underlined the important part. So let's start reading the question. An airplane flying at 450 km per hour. So basically 450 km per hour is going to be our velocity at a constant altitude of 5 km. So 5 km is going to be the altitude. Is approaching a camera mounted on the ground. Let theta be the angle of elevation above the ground at which the camera is pointed. When theta equals to pi over 3, how fast does the camera have to rotate in order to keep the plane in view? Notice that it says here, how fast does the camera have to rotate? So basically, the question is actually asking us, what's d theta over dt when theta is equals to pi over 3? Step 2, we're going to use pictures, so it will be much more easier for us to imagine what the question is actually talking about. From the question, we have already know that the velocity of the airplane is 450 km per hour. Since velocity has direction, so when the airplane moves, there is a change in direction. So the airplane is moving in horizontal line. So let's call the horizontal line as S. Notice that 450 km per hour is a rate. That means this is going to be the derivative. So it's going to be ds over dt equals to 450 km per hour. Therefore, it's going to be ds over dt equals to negative 450 km per hour. Step 3, we already know the airplane is flying at a constant altitude of 5 km. So we can add into the picture the altitude of airplane, which is 5 km. Step 4, we're going to add the theta of the airplane into the picture. Step 5, we're going to create equation and find s by using trigonometric function. So from the picture, we can conclude that tangent theta is equals to 5 over s. Next, we're going to find s when theta is equals to pi over 3. So we're going to substitute theta equals to pi over 3 into the equation. So it's going to be tangent pi over 3 equals to 5 over s. So we will move s to the left and tangent pi over 3 will go to the right. So it's going to be s equals to 5 over tangent pi over 3. Note that pi over 3 is 60 degrees. So we can substitute tangent pi over 3 to a square root of 3, since tangent 60 degrees is actually square root of 3. So s is equals to 5 over square root of 3. Step 6, we're going to find d theta over dt. We're going to differentiate both sides implicitly with respect to the time t. So we're going to add d over dt to the left and right side. So the derivative of tangent theta is secant square theta. Next, we're going to differentiate the inside. So the derivative of theta is going to be d theta over dt. So next, we're going to differentiate the right side. So we're gonna move s to the top and we're gonna differentiate it using the power rule. So it's going to be negative 5 over s squared, and s is also a function of time, so it's going to be ds over dt. Okay, notice that we have already circled secant square pi over 3. We're going to simplify secant square pi over 3 to 1 plus tangent pi over 3 square. Remember that secant square theta is actually 1 plus tangent square theta. So it's going to be 1 plus tangent pi over 3 square times with d theta over dt equals to negative 5 over s square times with negative 450. Remember that pi over 3 is 60 degrees, so we can substitute tangent pi over 3 to square root of 3, since tangent 60 degrees is actually square root of 3. So it's going to be 1 plus square root of 3 square times with d theta over dt equals to negative 5 over s squared times with negative 450. Remember that you have to always put it in radian mode. Step 7, 1 plus square root of 3 square is going to be 4. So it's going to be 4 times with d theta over dt equals to negative 5 over s square times with negative 450. So for our final solution, step 8, so we're going to substitute s into the equation. We already know s is equals to 5 over square root of 3. So it's going to be 4 times with d theta over dt equals to negative 5 over 25 over 3 times with negative 450. So when negative 5 over 25 over 3 times with negative 450 is going to be 270. So next we're going to move 4 to the right. So it's going to be d theta over dt equals to 270 over 4. So our final answer is d theta over dt equals to 67.5
rad per hours.
Next, for conclusion, as the question demanded us to find the speed of camera to turn as the airplane passed from it at the angle mentioned, so we use the information given to form a formula to find the distance between the airplane and camera. The velocity of the airplane will be negative since the airplane has passed the camera. We use implicit differentiation in order to find the speed of camera to rotate and substitute all the information collected. Last but not least, when we were solving the trigonometric part, we use radian mode for our calculator, and the final answer, or the speed for the camera to rotate at angle mentioned when the airplane's velocity is 450 km per hour is 67.5 rad per hour.